Hello students, today in this video we're going to look at solving inequalities. Now an inequality looks just like an equation, but instead of an equal sign we have an inequality sign. And there are a couple inequality signs that you need to know. This is less than, and then we have greater than, and we have less than or equal, and then we have greater than or equal. Okay? Less than and greater than, less than or equal, greater than or equal. Okay, and we'll talk more about those as we go. The first thing though I want you to do is to write this down on the side and maybe put it in a box or something, because this is the most important thing you need to know about solving inequalities. If you multiply or divide by a negative on both sides, flip the inequality symbol. I'll give you a second to write that down. If you multiply or divide by a negative on both sides, flip the inequality symbol. And I'll explain what that means as we go through, but I want you to have it written down because we're going to refer to it with every problem that we do. Okay? So, the first problem I want to look at is 5p plus 11 is less than negative 9. Now I solve it just exactly like I would solve an equation, unless this happens. Okay? But here, so I've got 5p plus 11 is less than negative 9, two-step inequality. So the first thing I need to do is subtract 11 from both sides. And I get 5p is less than negative 9 minus 11 is negative 20. Okay? So then 5p is less than negative 20. So to get p by itself, which is my goal in solving an inequality, I'm going to divide both sides by 5. Now, is 5 negative? No. 5 is positive, so I don't pay attention to this. I'm dividing by 5 on both sides, but I'm not dividing by negative 5. So I just do normal. This becomes p is less than negative 20 divided by 5 is negative 4. So the answer to this inequality is p is less than negative 4. Now how do we graph that on a number line? Well, let's draw a number line. And number lines always have arrows at the end. And the only really number I'm concerned about on this is the negative 4. So I'm just going to put a line there and put a negative 4. Now this inequality says that p is less than negative 4. So I need all the numbers that are less than negative 4. Well, is negative 4 included? No. It says it's less than negative 4. It doesn't say less than or equal to negative 4. So it's less than negative 4. So I'm going to put an open circle on the negative 4. That open circle tells me that the number is not included. And then everything less than that is going to be everything to the left. So I'm going to draw an arrow that points to the left from that circle. Okay? So we solved it, and then we had to graph it on the number line. P is less than negative 4. That open circle tells me less than, the negative 4 is not included, and then to the left is the less than. Well, this next problem we're going to look at is 19 minus 4n is less than or equal to 39. Okay, so we're going to solve it just like we do an equation. So the first thing I really need to get rid of is that 19. And since 19 is positive, I'm going to subtract 19 from both sides. So I do minus 19 minus 19. That cancels out, and I'm left with negative 4n is less than or equal to 20, because 39 minus 19 is 20. Now, I need to get n by itself, so I've got to divide both sides by negative 4. Ding, 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 ding. This is where this comes in. This says if you multiply or divide by a negative on both sides, flip the inequality. I'm dividing by a negative on both sides. Now because I'm dividing by a negative on both sides, I have to flip the inequality symbol. So instead of it being n is less than, we have n is greater than 20 divided by negative 4, which is negative 5. Okay? That is the most important thing. If you don't flip that inequality symbol, your answer is going to be completely wrong. Now let's graph this. So I'm going to draw my number line with arrows. I'm going to put a negative 5 in the middle. This says n is greater than or equal to negative 5. Since it's got that or equal to, I'm going to put a closed dot on the negative 5. And it says it's greater than, so I need all the numbers that are greater than or equal to negative 5. So my arrow is going to go to the right. Notice I drew the arrow on the line, sort of, and I put another arrowhead on it so that I can see that I'm looking for all of the numbers, including -5, that are greater than -5, that make this equation true. So if I plugged in a 10 into here, 19 minus 40, because -4 times 10 is 40, 19 minus 40 is less than or equal to 39. Well, 19 minus 40 is -21, and 21 is less than or equal to 39. So that makes the inequality true. So let's look at our next example. Our next example, sometimes I like to confuse this by putting the variable on the right-hand side. That just really irritates me, but we just keep going anyway. Okay, so I've got -8 is greater than or equal to 14 minus 2p. So the first thing I need to do is get rid of the 14. Because I'm trying to get p by itself, can't start with the 2, so I've got to start with the 14. So I'm going to subtract 14 from both sides. Well, -8 minus 14 is -22, is greater than or equal to -2p. Because, you know, those games lie. Well, now I've got to divide both sides by -2. Ding, ding, ding. Over here, I'm dividing by a negative on both sides. That means I have to flip the inequality symbol. So instead of greater than right there, it's going to become less than. So -22 divided by -2 is 11. And -2p divided by -2 is just p. Now here's the tricky part. When the inequality is on the right-hand side, I could, if I wanted to, flip the entire inequality statement, because this says 11 is greater than or equal to p. Well, if I read it backwards, I have to start with the p. It says p is greater than or equal to 11. So I could rewrite that as p is greater than or equal to 11. Both of those are the same. I like to have p on the left-hand side because it's easier when I graph it. Now notice that I didn't just flip the p and the 11 and switch the sides for the p and the 11. That would have been wrong because the inequality would have been facing the wrong way. I had to mirror the entire inequality statement. So let's graph it. We've got a number line. We have the number 11. It says greater than or equal to, so I'm going to put a closed dot. And it's greater than or equal to, so I'm going to draw an arrow to the right. And that is my graph of p is greater than or equal to 11. So the next example I want to do for you has variables on both sides. So just like when we're solving equations with variables on both sides, I have to start with the variable, I don't have to, I want to start with the variable with the smallest coefficient. So I've got a coefficient of -5k and a coefficient of 3k. The smallest one is -5, so I'm going to do the opposite of that, which is add 5k to both sides. And so I'm left with -20 is greater than 8k minus 12. And so now I'm going to add 12 to both sides. Add 12 to both sides, and I'm left with -8 is greater than 8k. And now, to get k by itself, I just have to divide by 8. Am I dividing by a negative on both sides? No. I'm only dividing by a positive, so I don't have to flip the symbol. So I have -1 is greater than k. And I could rewrite that if I wanted to flip the whole thing as k is less than -1. And then I have to graph it. So I'm going to draw my number line. I'm going to put -1 on the number line. Is it going to be an open circle or a closed circle? You're right, it's open. Now, which direction? It's less than, so I'm going to go to the left. And that is how I would graph k is less than -1. The last part of this that I want to show you is some weird situations. Okay? Let's look at the weird situation. In this weird situation, we got 5k minus 3 is less than 7 plus 5k. Well, I start with the variable with the smallest coefficient, but they're both the same. So pick one. So we'll pick a positive 5k, and I'll subtract 5k, and I subtract 5k. Well, those cancel out, and I have no more k's. So all I'm left with is -3 is less than 7. What do I do? Good question. Is -3 less than 7? Yes, this is true. When all your variables are gone, and all you're left with is a true statement, -3 is less than 7, then the solution is all real numbers. So I could plug any number in the whole wide world into this K, and I would still get a true statement. Okay? All real numbers. Sometimes you might see it as a capital R that looks like that. That is also the symbol for all real numbers. Again, solve it. No more variables, but I have a true statement. All real numbers. Well, let's look at another weird situation. We've got 5k minus 3 is greater than 7 plus 5k. We'll do the same thing. Subtract 5k from both sides. All those 5k's cancel out, and I'm left with negative 3 is greater than 7. Is that true? No. Negative 3 is not greater than 7. That's a false statement. And if I am ever left no more variables and I get a false statement, then the answer is no solution. There is no number that I can plug into this inequality statement to make it true. Never going to happen. Again, I'm done with all my variables. There's no more variables. And I'm left with a false statement. Then the answer is no solution. I hope you enjoyed this video as much as I enjoyed creating it for you. Stay tuned for the next episode of Algebra.